Hi students. Now we will discuss about Wiens Bridge circuits and its operation. Mainly, this Wiens Bridge is used to determine frequency. Frequency. Up to now, we have discussed different bridges like Whetstone, Kelvin's, Maxwell's, Hay, Anderson, and Sharing. Those bridges are used to determine the unknown values of the components. Now this bridge is used to determine the unknown value of frequency. So have a look here for the existence of the bridge. It is the bridge. And I'm representing here the points like is A and it is B and it is C or D. And I'm assuming it is the first arm, it is the second arm, it is the third arm, and it is the fourth arm. In the first arm, we're having the resistance, so it is R1. It is C1 capacitor in first arm. It is resistor in second arm. It is resistor in third arm. It is capacitor in third arm. It is resistor in fourth arm, R4. And it is source and it is detector. And while coming to the construction point of view, between the terminals A and C, we're having the series combination of R1 and C1. Between the terminals A and D, we're having resistance R2. Between the terminals B and C, we're having the series parallel combination of R3 and C3. Between the terminals B and D, we're having resistance R4. Between the terminals A and B, we're having voltage source, AC voltage source. Between the terminals C and D, we're having detector. It is the simple construction of the Wiens bridge. Now, while having here different impedances at the different arms, so have a look here for different arms. First, I will go with first arm. Here having R and C in series. So I'm writing here impedance Z1. Z1 equal to RC are in series. So equivalent value is R1 minus J by omega C1. R1 minus J by omega C1. Because we are having here R1 and C1. And second arm. In the second arm, we're having R2. So Z2 equal to R2. In the third arm, we're having RC parallel. So better to choose here admittance in third arm. Y3 equal to here R3. So I'm writing here the series combination Y3 equal to 1 by R3 plus J omega C3. And the fourth arm Z4 equal to R4. R4. Those are the impedances for different arms. Now, in case of AC bridges, the balancing condition is here. The resistance of product of opposite arms is equal to resistance of product of two other opposite arms. That means here 1, 4 are opposite. So, the balancing condition is 1, 4. That means Z1 Z4 equal to 2, 3. So Z2, Z3. And look at here. Z1 value is there. So substitute it. Z4 value is there. Substitute it. Z2 value is here. Then we can. Here it is Z3. Here we are having Y3. So we have to convert this Z3 into Y3. That means just I am taking this Z3 to this side. So I'm getting here Z1 Z4 by Z3 equal to Z2. Now 1 by Z3 is nothing but Y3. So Z1 Z4 Y3 equal to Z2. Z2. Now I'm substituting all these values here. First Z1 is here like this. R1 minus J by omega C1. So R1 minus J by omega C1 into Z4 is nothing but R4, and Y3 is nothing but this one. So 1 by R3 plus j omega C3 equal to Z2 is nothing but R2. That is the substitution here. Z1, Z4, Y3, R2. Just I'm simplifying here. First I'm multiplying with this and with this. So R1 into R4. Now R2 equal to R1 into R4. This R2 I'm writing here initially. R1 into R4. R1, R4. This one into this one minus J R4 by omega C1 into this same term 1 by R3 plus J omega C3. Now I'm multiplying with this the rest of the two terms. So R2 equal to this one into this one. R1 R4 by R3. This one into this one plus R1 R4 J omega C3. This one into this one minus J R4 by omega C1 R3. This one into this one. Here look at here, minus into plus minus J into J square R4 omega C3 by rest of the term omega C1. Now R2 equal to same term R1 R4 by R3, and here there is no simplification, so J omega R1 R4 C3. Here also no, minus J R4 by omega C1 R3. Look at here, it is J square. J square is nothing but minus 1, and this omega will get cancelled. So adding here minus into minus plus R4 C3 by C1. That is the term. Now I'm comparing real parts. Compare real parts. Here the real parts are at this side, this one, and at this side, this one and this one. So I'm equating those. R2 equal to this one, R1 R4 by R3, and this one plus R4 C3 by C1. Just I'm taking R4 as a common term from these two. So now I'm taking R4. So R2 equal to, by taking R4, the rest of the term is here R1 by R3, and here C1 by, sorry, C3 by C1. I'm taking this R4 to this side. So R2 by R4 equal to R1 by R3 plus C3 by C1. Write it as equation number 1. Equation number 1. Now compare imaginary parts. Compare imaginary parts. Here the imaginary parts are here. There is no part in the LHS side. So this one minus this one equal to 0. So I'm writing that imaginary parts are there. J omega R1 R4 C3 minus J R4 by omega C1 R3 equal to 0, because there is no imaginary part at the remaining side. Now I am taking this term to this side. So J omega R1 R4 C3 equal to J R4 by omega C1 R3. This minus will become plus, and here J J R4 will get cancelled. Then the rest of the term here omega R1 C3 equal to 1 by omega C1 R3. And I'm taking this omega to this side and this one R1 C3 to this side. So omega into omega, omega square equal to 1 by C1 R3 already existed term, and this one is R1 C3. Now omega square equal to I'm taking this square to this side, 1 by C1 R3 R1 C3. And here we know that we know that omega equal to 2 pi f, 2 pi f. Then substitute this value here. So 2 pi f equal to square root of 1 by C1 R3 R1 C3. And finally f equal to 1 by 2 pi into square root of C1 R3 R1 C3. It is the formula for frequency. That is the formula for frequency. And here, in case of Wiens Bridge point of view, that means in most of the cases, and assumed it is equation 2. Equation 1 already assumed, that is here it is equation 1. Equation 1. Equation 1 and equation 2. These two. Equation 1 is used to determine the resistance ratio, and equation 2 is used to determine the frequency. In most of the applications, in most of the cases, in most of the Wiens Bridge circuits, simply R1 equal to R3 equal to R, and C1 equal to C3 equal to C in most of the Wiens Bridge cases. Then from equation 1, what we have from equation 1, R2 by R4 equal to R1 by R3, C3 by C1. R2 by R4 equal to R1 by R3 plus C3 by C1. C3 by C1. Here R1 R3 means R, C1 C3 means C. So here from this one, R2 by R4 equal to R by R plus C by C. That equal to 1 plus 1, that equal to 2. So R2 by R4 equal to 2. It is the relation. That is R2 equal to 2R4. That means in case of Wiens bridges, the R2 value will be twice of the R4 value. Similarly, from equation 2, this is equation 2. Look at here, have a look here. From equation 2, again I'm substituting, then it will becomes f equal to 1 by 2 pi into square root of C1 means C, R3 means R means R, C. So that will gives us 1 by 2 pi RC. It is the formula for frequency in case of Wiens Bridge. Like this, we can find the formula for frequency and the relation between resistances in Wiens Bridge.